Hello, this is an off-topic announcement. So, just a reminder that you have to be self-reflective, okay? You are researchers, so you are reminded to write one sentence at the end of the day. What was the best thing? Be specific, what you learned, what inspired you, and also one sentence, what was the hardest thing or what was not clear. Also be very specific, don't write, oh, it was too much, or oh, I'm just tired. Okay, I'm passing the mic to the real leaders.
Thank you, Harald. And at the end of this very tough day, I present you the second keynote lecture of the Baltic Summer School of Digital Humanities. And our invited speakers today are programmers, developers from the Austrian National Library, Sonja Dorfbauer and Simon Meyer. And I'll give floor to you and introduce to yourselves and give your lecture.
Okay. So welcome everybody. We're going to talk today about structured data approaches and to historical collections and what are our methodological approaches and also what are our insights onto that. But before that, I want to introduce ourselves. So my colleague Simon Meyer and me, Sonja, we're both software developers at the Austrian National Library. We're in the research department for the digital library. And Simon's background is mathematics, and so he focuses mainly on machine learning and AI programming, and my focus or my background is computer science, so I'm trying to make a bridge between computational methods and the digital humanities. And today's presentation, we will present 3 projects from our department. So Simon will present the Prince Eugene's Library and the project about optical character recognition, so OCR. And I will be presenting the project about data analysis and the ONB labs. And another introduction, maybe you don't know it, the Austrian National Library. Our building isn't that new, as you can see in the picture. It's actually pretty old. It's from the 14th century. It's in the Hofburg, and it was back then, or its origins are from the Habsburg Imperial Court Library, and the job of the National Library today is it's a legal deposit library, so everything which is published in Austria goes to the National Library as a copy. And yeah, as you can see in the picture, it's stated at the Hofburg, and for example, it also holds the Prince Eugene's Library, which we will later talk about. But what is our collection actually? So we have a pretty broad collections. So we have, for example, starting off with a papyrus and also like music notes, reaching over to globes. So we have a really big scale actually, which makes the digitization pretty hard, let's say it like that. But maybe to give you some numbers, we have over 200 million plus pages on books digitalized, which is over the project Austrian Books Online, which is in cooperation with Google. So this really helps us to get this amounts of digitalized pages. And for example, these directly go into the project we will be presenting today. So this digitalization projects are like the base. And just having like scanned texts or like scanned books isn't structured data yet. So our task and our job is that we're like right in the middle in between. So like how can you actually get from these scanned books to really structured data, and how can you make computational methods on top of them to get cultural insights. And this is also like one role like we have in digital heritage. So we really want to make the computation like we really want to make it accessible for everybody, and we also do that through other projects. So we also have Anno, this is Austrian newspapers online, which we will also later talk about. And then we also have Alex, this is about the historical legal texts. And Abo, I already told you. But how can you get, so to say, this bridge? So our goal is, how can you get from the digitized object to actually structured and then to the meaning out of it? And with our lecture today, we really want to actually close this gap on showing cultural data analytics and how to get meaning out of it in practice. And that's why we will be presenting those 3 projects. First of all, Simon will present the BIBLIOTÄKA Eugenia Digital. So it was about reconstructing a lost collection. Then I will continue with the ONB Labs and the Jupyter Notebook projects. And then we will have a short break because everybody is a little bit tired, and you can already ask questions in between because the projects are kind of independent. And then we will continue with the OCR service, which is called Many Voices. And in the end, we will have a kind of takeaway and sum up discussion. And I think then I would hand over to Simon, and he can start.
Thank you, Sonja. And I would like to also thank the organizers for inviting us and for having us at the summer school. It's a privilege to be here and to be able to present our work. And the first project that I want to tell you about is about a Baroque library. And already in the name and on this picture, you can see that there are some old books. And the thing is, these old books are part of the basic collection at our National Library. So there's the State Hall, which by now is more a museum. But what people don't know is that it's actually also part of the library. So in this picture, which is like an excerpt from our title picture, you can see some books in the background. And these books you can actually borrow, as in you go to the website and you click on borrow, and then you can go and look at it in the reading hall, because it's a presence library. You cannot take books home, and of course not the historical ones. But what most people don't know is that all these books you can borrow, and visitors are mostly told that all these books are from Prince Eugene, and that is not really correct, because this State Hall was built in the 1720s, so more than 300 years ago, and it was filled at first with some books, and then later Prince Eugene's books were put there, and then even later other books were put there. So by now it was not clear which books were where and where Prince Eugene's books were. And in general, because there are so many books in the State Hall, it's too complex and too extensive for one person to order this whole thing and to gain insights into it. And first of all, some background on Prince Eugene. You can see him here on the right side. He was a famous commander, military commander of the Habsburg Empire, lived in the late 17th and early 18th century. And he was famous for his achievements on the battlefield, but during the later half of his life, he was also a book collector, arts collector, and a patron of the arts. And this is reflected in the size of his private library. It was estimated to be around 15,000 printed volumes, almost 500 manuscripts, and then also other things that were bound, like engravings or portraits. And after his death in 1736, since he had no heirs, the library was then sold to the Emperor Charles VI, and at the time it was worth more than his palace. So this just goes to show you that back then historical books are just the valuable books that were made, they had such big value that if you took the sum of it, it would be more than a castle. And this collection was then included into the Imperial Court Library, which later became the National Library, but it was never systematically reconstructed, as in it was deconstructed by the library practices. Like the book was put in a shelf, and then it got a shelf mark, and the shelf mark itself carried Prince Eugene's name. But later, other books were put in the same shelf and received the same shelf mark. So then, a couple years later, you cannot tell anymore by the shelf mark which book was from Prince Eugene. And that brings us to the research questions, which we tried to answer. And I mean, with some of them we had success, with others not, but it was anyway great fun to work on them. And of course, what is the exact composition, as in what books did he have? Because there is a handwritten catalog that I will tell you about later, but it's also very extensive and slow to read through. So we would like to have a visualization, like a quick overview, what is in the library and how many books were part of it. If it's 15,000, then you can spend a year to count them, but it's not very fun to do that. And where are these books today? We had the suspicion that most of them would still be in the State Hall, in the central oval that you have seen on the pictures, but some of them were moved to other departments because they fit nicer there. And since they were, among the nicest books, on the left side you can see a Bible by Luther that has a very nicely manufactured leather binding. And then where would so there were reasons why these books were then moved to other departments, because they also like to have nice books. And then the final question that ties back to this summer school: how can this collection be made accessible and explored online so that other researchers like yourself can then take the research further? Because before it was really inaccessible because the books are just there, and you have to go there and by hand pull out a book to do research on it. And as Sonja mentioned, the first step, of course, is the digitization. So then in help with Google, by help from Google, we were digitizing all the historical books, and they were available online freely, but all of them without structure. So we have to somehow collect only the Prince Eugene's books digitally and then make that accessible. Yes, and I forgot to mention, so the meaning or the importance of this library was recognized already some years ago. In 2014, our library applied for it to get some UNESCO Memory of the World status, or Memory of Austria, which is the national version of Memory of the World. And that means, okay, it's important and it deserves to be preserved. But to reconstruct it was not done until our project, which was running from 2022 until 2024. Yes, and for all the reasons that you just heard me say, the reconstruction of this collection is not so easy, because many things play a role, like how do we interpret all these different factors that I mentioned, and also that it should be available for a longer amount of time, because the scans that were made, they were already maybe now harder to access, some 10 years later, and so on. So a couple words about the data, because today we're already playing around with data. We were, just importing a CSV file, and we're happy with that. But then at the start of our project, we didn't have this CSV file. We had to, we have to go to librarians, ask them to write us a query into the catalog, and then finally we get corresponding catalog entries for the State Hall, so that you can see on the bottom right. So because the modern library catalog is huge, it contains everything that is available in the library, so it has millions of records, and they are growing all the time because every year new books come. But we're not looking for those, so we just need to request the old books that are somewhere. And we took some time to figure out with the librarians how to do that, and we managed. So then we had this CSV file for the modern library catalog. And then we also had an old catalog, the handwritten catalog. It was written back then in the time of Prince Eugene, when they sold the library to the emperor. And since it's handwritten, it already poses other challenges, as in it's an antique handwriting, hard to read, and especially hard to read for a machine. And yeah, in the project we could luckily do this. We could train a handwritten text model, and I will explain a bit about that. And finally, as you have seen on the previous slides, I will pull it up again since it will only come a bit later. You see on this book, there's like a nice coat of arms printed in the center, and many of Prince Eugene's books had this feature on them. So that's like a clear indicator. If there is such a coat of arms, which is of course his, on the book, then the book belongs to him or belonged to him. So that was our indicator on how to identify visually the book. And if you take all of this together, hopefully you will have a good recollection or reconstruction of this collection. Okay, some words about the handwritten text recognition. We used Transcribus, which was already mentioned in the summer school a couple of times. And yeah, I don't know if you want to know more about this, because this program has been around for a while, and I assume people have used it in their studies or later once at least. So I will keep it short for that reason. So basically we used some models that were already there to check where they are, which level they would get us for 18th century handwriting. You can see them in the diagram on the left side. So they have some word error rates which are not acceptable. So then we realized, okay, we need to train models, and to do that, you need to type down the content of the page manually, and you have to do that for like 30, 40 pages, and then you train a model, and the resulting model that we got was pretty good, in the sense that on regular pages, you only have around 3.7% error rate, which is really good. So, you know, the baseline, the human baseline would be around 5%, because humans make mistakes. If you let a human work on this for 4 hours, they go crazy and they make some typo. Or maybe, you know, they get depressed. So then we don't want that. And the machine in this case is even better at 3.7%, but it still makes mistakes. So we were then manually just reading through the text and only, you know, typing once in a while to correct the mistakes that the machine made. And that like gave us a really good result at the end with only like, you know, moderate effort. Yeah, here you can see the differences between regular and irregular pages. So on the right side, there's a regular page where the scribe was really like focused and did not make single mistakes. On the left side, you can see something was crossed out, and also that the script is not very straight. Yeah, and of course, the left side is also hard for the machine to read. In that case, we had to type manually. And it also occurred in this manuscript that the font type changed, so to speak. So right now, this is a Latin handwriting, which is kind of okay to read for a human, but then we also had some Kurrent, so like later German scripts that probably, yeah, were written down later by other librarians and not Prince Eugene's. So they are still kind of interesting because they indicate books that were later added to the collection and then written down in the same catalog since it was already there. But then, you know, that's not, those books were not by Prince Eugene, but we could tell that because the year of publication is, of course, after his death. So it's not a real problem for us, like a source of errors. Okay, another method, as I mentioned, we were looking at the coat of arms. And here you can see the 3 different variants of these coat of arms that Prince Eugene had printed on his books. And we trained like a simple classifier algorithm to recognize these coat of arms. And that is like, as far as machine learning goes, it's a pretty simple task. As in 10 years ago, that was state of the art, or I think even more than 10 years ago, but by now it's very easy, and you can do this on a laptop. And yeah, so this, you can see below, like there's some plots, and then that tells you that like the performance of these models is pretty good because everything is pretty much near 1.0 as far as the prediction of this algorithm goes, and the parts where the algorithm is not sure, which is further left, away from the 1.0 prediction, that is then maybe also wrong. So the wrong ones are yellow parts in the picture. So then, you know, you can check the wrong ones manually, which are a few, and the ones with high prediction with a high probability, you can just believe them. And we did, of course, some sampling, and yeah, the ones that where the probability was high, they were all correct that we sampled. I mean, we cannot be sure because we didn't look at all of them, but yeah. Oh yeah, and for this, since for us it was also a point to think about how to explain these results, because this one right now it looks like a black box, right? So you give the machine the image and the machine gives you back, yeah, this is A, B, or C, or not Prince Eugene. And on this slide we tried some algorithm that explains what the AI does, or where the AI looks to make its prediction. And that's visualized as a heat map. So red parts in the image is what contributes to the prediction. And we're happy to see, you know, that where it's red, that's where the coat of arms is. So that means the algorithm took the pixels that were part of this coat of arms and then said, yes, this is from Prince Eugene. So that's like as good as it should be. Okay, are there any questions, by the way? Yeah, please. Maybe we should, 1 second. We're just waiting for the microphone.
Thank you very much. Great lecture, and very interesting for me since I'm also a mathematician. So most questions I have according to measurement, comparing metrics between models. So you mentioned ResNet, convolutional neural network. Did you also try some other models from the net, let's say family of neural networks? Also, did you try VLM? And considering metrics, I believe you compare F1 precision recall, not just accuracy. So what is the best metrics for these kind of data sets that you have, and how much is the size and the volume of the data? Comparing validation, training tests, so I saw that you also have validation sets, so this technical part, considering these.
Okay, I haven't prepared the numbers, but from memory I can give you like a rough estimate. So the training data set for these is like 200 each, and then, you know, around 1,000 negative examples. Because for these classifiers, you want to be sure that that the whole setup is good, as in the training data needs to be solid and it needs to explain all the classes that appear. And we saw, you know, that you can see the rightmost coat of arms, it does not have the ring around it. So that's already visually different. The thing is, in the negative data set that is coat of arms that are not Prince Eugene's, you see a lot of other coat of arms that also don't have the ring, and then they were visually similar to each, and that's why the algorithm had difficulty distinguishing them. So then we had to put a lot of negative examples that look exactly almost like the one on the right, but they are, of course, slightly different, and that improved our performance a lot. And yeah, I mean, back then it's already, you know, more than 2 years ago, so I don't know all the details, but of course we looked precision recall and we checked all these numbers, and then, you know, we fed this classifier through all the historic books in the State Hall, and that's like around 150,000. And of course I don't know, so we did not check the negative results, but I think for the positive results we checked all of them, and that's why, you know, we could tell the yellow and the blue color in these plots, and that's like 6,000 or 7,000 data points that you can see up there. So not too many to check, but yeah, we had the help of some interns that were given the task, okay, check this list, look at these images, and then click yes or no. Yeah, and the first question, we tried also other machine learning tools, or like other networks and such, but, you know, they were slower or worse than the ResNext family. And then we thought like, why not keep this? Because the answer we get is already good enough. Because of course we could have invested more time, more effort to get actually a little better performance, but then also it would take a longer time to build up the whole pipeline. So then we went on and we're like, okay, this is good enough, because like the number we got, this more than 6,000, that's already like a believable number, because at first it was not known how many books had this coat of arms, because Prince Eugene also had other books that did not have the coat of arms, and this fraction was not known at the start. So then the 6,000 was, no, that's good enough. We don't need to, like, we're not forgetting another 6,000, because that would be, I don't know, I just didn't think it was likely that our algorithm is performing so well on the ones that we see and misperforming on all these other ones that are in the dark negative prediction bag. Yeah. Okay, thanks for the question. All right, then I mentioned also, you know, how we bring together all these data points. And yeah, one important task there was to string match the historical handwritten catalog with the modern catalog, because those are just so different. As I mentioned, the modern catalog is in Mark XML, so it's very structured data, but yeah, it's very big. And then the handwritten catalog, we digitized it only into text. So it's, you know, a string starting at the beginning of the handwritten catalog, and it ends at the end of it. And so we had to do still some work. And we managed to do layout analysis on this handwritten catalog. You can see the orange rectangle. That is one unit of text that we got extracted from this handwritten catalog. And yeah, I apologize, it's a little bit small to see here, but basically one paragraph of text corresponds to one book. And in this paragraph of text, there is a textual description of the work, which is in Latin and in a certain order. And the recognized text, you can see it on the right side below. And that we had to match with the metadata from the modern catalog to see if the book is in our modern catalog, and that way we can connect the two inventories. And yeah, the way to do it is via fuzzy string matching, where the order of the words is not as important, and also the differences in plural, singular, and different ways of writing. So the details are on this slide, but I think it will take us too long to go more into it. I hope you will get these slides after the school, so that you can read up a bit. Also, we were happy to receive questions by email. Yeah, please feel free to reach out. Yeah, so what I can mention one fact that we actually got out of this, as in there was an assumption from historians carried through the years, recent or more recent at least than the collection from 1986 states that the colors of these leather books correspond to the content. As in, theology is mostly blue or law, and then in red you will have history and poetry, and in yellow you would have natural sciences. And our data showed that, you know, one direction is correct. Like a blue book contains theology, but the other direction is not correct, as in red or yellow books also contained theology. So the historians back then, they took some samples and were like, yeah, this is mostly theology. But they did not take samples from yellow and red to find the ones that were also theology. So then, yeah, this we could disprove, and we also wrote a nice publication about it. Okay, so then we have a lot of data, and yeah, as we saw in the workshop earlier today, we want to then visualize it. And we did also such a workshop with a different audience, but with 14 stakeholders that we assembled from library and the network and everything. And yeah, we told them to behave as one of our 4 target audience groups, so historians, librarians, tourists and guides, or students, teachers, pupils. So because we didn't have, you know, representatives from each of these groups, we're telling the people, okay, yeah, behave as a school student and yeah, think about it this way, and then how would you like to see this collection, or how would you browse it? And we used a white loss concept of generous interfaces. And to keep it short, I will just show you the result. It's an interface that consists of 3 parts, and it's not very easy, but we hoped that people would be, you know, willing to interact with it and then find out what it's about, instead of giving them a lot of tutorials on how to do it. So on the left side, you can see the list of books. So you still have something to look at. In the middle is an overview of the State Hall, the central oval where most of the books are, and you can click on a shelf and then you can locate a single book and look at it, look at the digitized version of it. On the right side, you will see some analysis views. For the screenshot, I just put like amounts of books that were classified as belonging to Prince Eugene or not. And then there's of course some books where we don't know yet. So that's where like other people can come in and like do more research. Are these books from Eugene or not? We don't know yet, but yeah, feel free to spend some time on that. And yeah, the outcomes of this project were the digital edition of the handwritten catalog, because we had all this text and like text with markup, with the layout analysis, and then this visualization prototype. You can find it on these links that I've written here. And of course a data set, like the data set that I mentioned before the visualization, that you can download as well on our website. And yeah, a couple publications also, and media coverage in a newspaper. Okay, so what are takeaways for this part? Reconstructing a collection is half the work. And because, you know, with machine learning and the matching pipeline, we could answer the what and where, but like the how to visualize it is all the other half, and that way we can like show this collection to the public and really help to like open it. Okay, and this part, I'll pass over the mic to Sonja for to present the O&B labs. Yeah, there's a question. We should get the microphone in the middle.
So thank you so far. Maybe I missed it and you already told it, but I was I was looking at your project site, which is very nice. I was wondering whether your findings are in a way represented in the now library catalog and the discovery system you're using, and how you managed to do that, because I think that's part of the visualization.
Yes, so the results, I mean, in this visualization, I mean, you can see, you know, what is Prince Eugene and what is not, but in the modern discovery system of the library catalog, you can also see it. You have to like, it's a kind of complicated, because you have to find previous owner and then Prince Eugene. So, you know, if I show you one example of a book that belongs to him, then you can see previous owner, and then you can click on it and you can search for other books that have previous owner Prince Eugene. So yeah, I can show you later how you can do that. So it's in the catalog and it's visible, but it's not very easy to find if you don't know about it. But yeah, we don't know yet what is the best way, because, you know, the catalog and its interface, that's very rigid. We cannot update it like just like that, because there is a whole, you know, all the Austrian libraries are in the same like compound, I don't know how to call it. Yeah, it's like a union of libraries, and they all have the same system, and they use the same way how to, you know, fill this catalog with data, and also how to query it. So we cannot change it by ourselves, but we are adding like these in this field, because that's like, you know, it's a factual, correct, we hope, thing about this, and then you can search for it by doing that. And the more technical results, like the colors of these books and like what kind of coat of arms is on it, that we put also in the catalog, but only inside a local field. So you cannot see it, but our librarians can see it. So we're like, okay, for later, maybe they will find a better way how to write it into the public part. But yeah, thanks for the question. Okay. Other questions? Yes, on the left.
I have a question about this fuzzy string matching. I'm thinking about how people could use it. So I wonder, I would just love if you could share a notebook with a code, how you do it, because just for people to see how it's being done, because it's a task which people quite usually do in digital humanities. They make their own corpora, and then they need to find some fuzzy string matching. So I wanted to ask just a general thing. So was it something based on regular expressions, or did you also try something large language model related, so that you just ask it to do it and then you evaluate results?
Yes, thank you. I mean, thanks for the question. That is, I just went briefly over this, but since the project, you know, it started in 22 and no one knew yet about large language models, and it finished like summer of 24, and then the rest of the time was spent writing the report. So we didn't use any large language models, but we instead used fuzzy string matching, so like Python libraries. It's called the fuzz. I will give the organizers like a link to this notebook. This is all open source. So then maybe, you know, Harald can write another email this evening and there will be the link to this. And yeah, it's basically, it's not very complicated, just a, you know, Jupyter notebook where you compare the strings and then you get a ratio. And if the ratio is high enough, then that's a match. So then, you know, it's you compare, you know, two big lists with one another, and then you get, we chose up to 5 suggestions, and then we manually compared the 5 suggestions to the catalog entry, and then we said, the human said, that's a match. So we didn't have completely automated matching. I think these days with large language models, you could do that, because the large language model could then flag uncertain cases for you and completely match automatically the certain ones. But I mean, I would do it completely differently if I would do it today, for sure. Yes, exactly. So the question is about syntactic matching between the catalogs. Yes, exactly. The meaning is not contained because you know you just compare characters that are similar to one another, and the meaning gets lost. And this is one of the drawbacks of this method, as in the handwritten catalog, you would have shorthands, or if the author would appear twice, the second time the author appears, the scribe would say the same. And then, of course, if you compare only this part, you don't know what is above, then you don't know who is the author. And yeah, we realized at the time that it's like, this is not perfect, but yeah, it was good enough back then to suggest these matches, because the first entry was then among the 5 suggestions anyway, because the author matched, and that was good enough to get a good score. But yeah, that was clear to us back then. But the, you know, this structure that author, title, place, and year was all present in the handwritten catalog, and we can concatenate the modern catalog and then compare these two, then it was already good enough for an approximate match. But yeah, I will give you this notebook. I mean, the GitLab repo that we have is open for everyone, so you can just take the code and like use it, but maybe it's not the best by now. Maybe now it's outdated, but it should still work. Okay. Any more questions? Otherwise, I think we have to go on because I'm out of time for this slot, because we have 2 more projects to cover. Okay.
Okay, so then I will continue with the second project I've told you. So Simon talked a lot about one collection, but in the National Library we also have various other digital collections. So where are they published? So that's why we want to present you the ONB Labs, which is the library's platform for exactly this digital collections as data. And with the labs, we have the goal to promote researchers, and we want to inspire researchers to use these digital collections and do like active experimentations and also like artistic usage maybe. So with the data sets we publish, we follow the collections as data principles. So first of all, we transform the library holdings into structured data sets, like we've worked with some today, like so you can simply download a CSV file and you can work with that, so that you really have this low barrier, so and everything is all open access. And the most important part is making exactly this library holdings, making them ready for computer processing and having the structured files and metadata to be analyzed. And the ONB Labs, we basically focus on two tasks. So first of all is the data sets on the right side. So we have various data sets. So maybe you ask yourself how we select those. So First of all, some are parts of digitalization projects or research projects, as I told you with the Austrian Books Online, for example, and other data sets are simply other departments come to us and we have an exchange with them, and then we're like, oh, we don't have any data set, maybe we should offer one to the public. So it's also an exchange inside of the library. And also another part is, parts of exhibitions. And I think here on the screen you can't really see it good, but what are like standardized formats we offer? So we offer various formats. So for example, the classic CSV files, but also for OCR, we offer like the XML or the text files. And for images, we follow the IIIF manifests, and we also publish the JSONs to that. But we also publish a lot of tools, which is on the left side and which I want to focus on. So one big part of the labs is also to offer various tools and explorers to help people who maybe don't have that much of technical knowledge to work with our digital collections. And that's why we want to make a little bit of advertisement for our GitHub. So you can definitely go there and check it out. And everything is open access. And for us, it's the perfect tool to offer everybody to have this low barrier again, so everybody can access them. And on our GitHub, we right now mainly focus on Jupyter notebooks. So I'm curious, who has worked with Jupyter notebooks here? Maybe a short hand raise? Okay, and who knows what Jupyter notebooks are? A little bit more. Okay, so I know how much I need to go into details. So basically, Jupyter notebooks are interactive programs where you can run Python code. And the big advantage of them is that they don't look like scary programming code, because you can have two types of blocks. First of all, you can have code, which is Python code, which you can compile. But the good thing is you can put as many text as you want in between, and it simply looks a little bit like a Word document. So you can really document what you are doing, and also other people can document it. So you can follow, for example, instructions, even though you wouldn't know how to program it. So it's really good to have this low barrier. And maybe I've talked too much about how they look like, but you haven't seen them yet. So this would be one Jupyter notebook. I have to mention, I'm really sorry, the screenshots are all in German, because we only published them in German. So this is a screenshot from one Jupyter notebook we have, and here you can really see a short introduction, what the code cell will do, and then you can just follow the text, what it tells you, and you can simply just press play, and the code will do whatever it is programmed to do. And I've already talked a little bit about it, but why we focus so much on Jupyter notebooks is the bridge between the data and the analysis. So for us, this really closes the bridge for getting usable insights. So on the right side, we have a picture of the life cycle from data analytics, and it's basically 7 steps. And the good thing about Jupyter notebooks is Jupyter notebooks are everywhere inside of this life cycle. So when you start off with the problem definition, you can define your problem inside of a Jupyter notebook. In the second step, where you get the collection, you can do this as well in the notebook. And for example, the data cleaning, which would be the third step, you can also do this in a Jupyter notebook. But the high advantage is you don't need to follow the whole pipeline with one notebook. You could, for example, like we did it today, do the data cleaning with OpenRefine and then use the clean CSV file and just load it into the Jupyter notebook and start from the third step. So it's a really good template, basically, and you can have the whole life cycle inside of one document, which also has the advantage of being really, transparent. You can just see what it does. There's like no hidden code or anything. So that is also a really good low barrier to enter. And also a big advantage is most of the time no software setup is needed because you can run it in the browser, for example in Google Colab, so you don't need to download any other software. So this makes the tools, Jupyter Notebook, really important for us and for the work we do with the OMB labs. And to show you some work we've done with the OMB labs and Jupyter Notebooks, I will present you some. So first of all, it's with Anno, and Anno is the Austrian newspaper online tool. Basically, on the right side, you can see a screenshot from it where I searched summer sun, and then I get a lot of findings where in old newspapers or in old magazines, the word summer sun was found. And then you can see on the screenshot on the bottom, on the slides you can see it, maybe here not that good, but there is a small rectangle where the text is like highlighted, and then you can see, you can read it up again. And maybe some interesting facts in the Austrian newspapers online, we have roughly about 28 million pages, so it's a lot, and it's way too much to make any analysis out of it. Like you can check it out on the website, but you cannot really make any visualizations out of it. That's why we developed a Jupyter notebook for it. So because there is an API, our library has an API for it, but in the labs we often get questions, how does this work, or how can I get, like, for example, this metadata? So we developed a Jupyter notebook which exactly shows how this usage with this API, with this programming interface works. And here it was really important for us to really have this low barrier. So on the screenshot you can see, you just click on the box, it runs the code, and it just gives you interactive widgets, so you don't even need to do anything in the programming code. So here again, really low barrier. And for us, the important thing was here that for the first time you could really get visual insights on, for example, what is the so how many magazines are on the topic summer sun, and this you can't see online on the website. So this is a thing you can only make visible through data analysis, which we did with the Jupyter notebook. Or another one is about the catalog we have in the library. So probably, it looks maybe similar. You can simply just search online for a book or something else you want to look at, and you can see where is it, where is the collection, where is it in the library. And for that, we have like 2 standardized metadata standards. So we have SAU, which is the search retrieve via URL, and then we also have the Open Archives protocol. And these are also like kind of 2 more technical interfaces. So here it was also important for us to develop a Jupyter notebook where you can where you can get results basically from all of the catalog's works, which is like really high data, but you normally don't see it on the website. But with a notebook, you can for the first time make some insights out of it, which are really, which are just hidden, but the data is already here. So here making this accessible was really important. For example, the picture on the top right, we had a search in the catalog about Adelheid Popp. She was a really famous politician in the Austrian woman movement. And with the notebook, we could, for the first time, visualize how many books were published when she was still alive, which is the blue ones, and how many were published when she was already dead. So this is also a pretty good cultural data insight, which you wouldn't get out of just simply looking at how many books are in the catalog. Another notebook I want to present is about the web archive we have in Austria. So the World Wide Web is part of the cultural heritage, and we, with the Austrian National Library, we preserve the online media, so we archive everything in the .at domain and everything which is like related to Austrian websites. So the web archive preserves exactly this. They do this since 2008, and there are almost 6 billion items, and they take, I have the number, they take over 327 terabytes of storage, so a lot of data. And the web archive also has a website where you can search for it, but they also have a programming interface. And here again, like with the newspaper notebook, we wanted to face the challenge of, can you get insights into the data which is already online, but maybe get those insights even though you're not that familiar with how to make an API call. And just so for that we developed a Jupyter notebook, and here we try to make exactly this bridge, and that's why we also offered like a beginner's notebook and a more advanced notebook. One other project is about a special collection we have. It's Ariadne, and Ariadne is the women's and gender-specific documentation center at the National Library. They work, it exists since 1992, and they collect current research literature, document like new acquisitions, and also make like indices like in the catalog which is already existing, and they give them like feminist keywords. And this exactly like this historical sources which are already at the National Library and which were found from the Ariadne team are the results which are in the or on the website Women in Motion. So the Women in Motion project mainly focuses on who were the women, who were the politician, what movements did they do during the Habsburg monarchy and during the interwar period. So all of this data is simply online on a website. So for us here it was tricky because there is no structured data set. So on the right side you can see it's a website, and it has a listing of all like ABCD, And then you can click on it, and then you can see, oh, there is like the academic women in Austria, and you can see what name it has, when it was founded, and you can get all of this information. But there was no simple CSV file which we could work with. So here we developed or the goal was to develop a Jupyter notebook to exactly get this information, structure it, and then get information out of it. Because right now we can see that exactly this academic union has two, or is like a union from another, from another club. So basically, there is a lot of information which you can't really get out of the data. So that's why we used geo-programming there, because we have addresses here. For example, when this club was at which address, but we don't have any latitude or longitudes. So we used geo-programming and searched up those addresses to get, to give this data a spatial context. So with the spatial context, it was, for the first time, it was possible to structure it geographically, and also to make visualizations. So here you can see the connection. If you click on the map, and you can see exactly this club was connected with another club, and for example, how close have they been, or how widespread maybe were the club's connection in Austria or in Vienna. So here, structuring and for also giving it a spatial context was a really, really important insight we only gained through working this whole data lifecycle with our Jupyter notebook. And another project which also focuses a lot on geographical data is Austria and aerial views. So we have a collection with images and metadata of aerial photographs from 1940 to 1945. And on the card, you can always see the picture of how this certain area looked like. And on the right side, there's always the text, for example, where it was. So it had the name of the place, like aerial view, Vienna 15th district. So it had roughly an address, but not always super accurate. That's why there was a crowdsourcing project in 2018 where people could georeference exactly this aerial view pictures. And so the crowdsourcing project focused on people who are like, I know exactly where this was taken from. This is the latitude and this is the longitude. So with that, almost 50% were georeferenced, and we had the thought that we could use georeferencing again and reconstruct the other parts. So we exactly took these names which are on the card and searched them up. For sure, they are not that precise. But we tried to kind of emphasize that in the map we produced. So we have two colors, blue and purple, and the blue ones are computed from us, so you know that there could be a mistake, and the purple ones, these are the crowdsourced aerial view pictures, so you know they should be highly accurate. And this brings me already to my last slide. So what are the takeaways I want you to have from me talking a lot about Jupyter notebooks is that structured cultural data isn't just one format where you can simply open a CSV file and you already have insights out of it. You really need to do a whole or not always do a whole, but you have some kind of life cycle. And Jupyter notebooks are really important for them because you can clean them, you can visualize with them, but you can also just explore with them. So it's a really low barrier where you can enter, and it's really nice because you can simply reuse them quite often. For example, with the Women in Motion, the georeferencing, we could reuse that also for the aerial infuse. So we already had a pipeline which we could reuse and which is online on our GitHub. So yeah, I think that's everything I want to say from my part. We can now either do a short break, or if there are questions, I'm also open for questions.
So let's do a break and ask questions during the break.
Yes.
So I'm looking at the audience. Raise your hands. I also have some comments and questions, maybe. So while the audience are still thinking,
There's a question.
Yes.
I will be short, not so much. It's great presentation again, so thank you. And since you are using Jupyter Notebook, and that is something which implies maybe cloud services, did you think about Microsoft Azure, AWS, something like that you connect with also ML models, data analytics, reports such as Power BI, Tableau, or something like that. So in that case, you wouldn't be, let's say, you wouldn't just develop from yourself, from the scratch, that API tool it is great, but you will have everything about data analytics from this report system. So all analytics could be covered within cloud, and do ONB, I mean your let's say, BIBLIOTÄKA or library system has that kind of cloud services that cover everything, yeah, from inside.
So we don't have that for the public, or like we have it for us developers. Like we have a Jupyter server where we really have like high power, where you could run exactly those machine learning notebooks. But having them in a cloud, we don't offer that. We were actually because the notebooks, they are all through, are all developed because of a project. And with the project, we were thinking about also hosting such a cloud service. But then we more or less ran into basic problems, like how do you give people credits? Like how do you make this accessible so that not just one person uses the whole project budget with the credits? So this was more of a practical solution, so to say. Yes.
So I'm looking around.
Thank you for a very interesting project, sharing an interesting project. So my question is about your team. Who leads these interesting projects other than you who have a computer science background? Are there any humanity background people, and what are the makeup of your team?
So basically when the project, so in the labs team, we are 4 people. And we have Simon and me as 2 software developers. Then we have Johannes, he is more of a project manager. And Christoph also has more of computational background. So from us, we don't have that much of a DH background. But for example, with the notebooks, when the project started, we made like a survey inside of the library and also outside through this Claria umbrella, basically, where we were asking, hey, do you have like interesting ideas or maybe data sets where Jupyter notebooks would be really good? And here we gathered also ideas, and basically we outsourced that knowledge a little bit.
Okay, I have two mics now. I have a question on behalf of people who are humanists and who are just starting with digital stuff. And I also really love Jupyter Notebook. And so thinking about how to lower the barrier, I have actually found it useful not to speak so much about Jupyter Notebook, but say Google Colab. Because it sometimes is that I say Jupyter Notebook and people say, I don't really understand it, I like Google Colab. And then I say, hey, you're actually using Jupyter Notebook, but in Google Colab. So I'm thinking how to make it even simpler, but what is your experience? Because maybe there are some other platforms besides Google Colab where it could be used. And another question is, nowadays there are those AI tools sometimes offered inside Jupyter Notebooks or in Google Colab. Would you suggest users to use those AI tools to explore their data sets? I know it's a kind of unorthodox approach, because if you don't know what you are doing and then you add AI, then you do a lot, but you don't know actually what it is. But on the other hand, like, maybe there are some safe and smart ways to apply those AI tools, because with the widgets we are already moving in the direction that the user is just clicking play and not really understanding every code. So this is more about, yes, science communication, engaging community. What is your experience on this?
So for the first question, yes, Google Colab definitely. One way to go to, because I would say, or I would assume many people have Google accounts, so you can simply use that. With our GitLab, we included Binder, which is basically a tool where you can upload the Jupyter Notebook and you can look through it and you can run it in the browser. So we have in the README file of the GitHub, we have a button where you can click it, and there you can already like look through it without even downloading it and uploading it to Google Colab. So we basically try to be like one step before, but it is definitely a challenge to explain people how to get from a GitHub page to uploading it somewhere. And for the second question, I would say, yes, use AI. It's a tool. It can help you. Like, you can, for example, if you have a problem and your Jupyter Notebook doesn't start because you didn't import something correctly, with AI, with this tool, it can help you by getting a solution maybe more easy. So that's why I really like, for example, this tool Jupyter Note. It's some tool and it's basically using GPT in the background, and it's like a little chat box inside of the notebook, so it can really see in which cell you have a problem, and there you can just limit it to one cell, so it doesn't happen that all of a sudden AI rewrites all of your programming code.
So do we have another topic?
Yes.
Yes. Then
So
maybe let's move forward and then continue.
Exactly,
with
because
questions.
that's the time we thought to have the break for. Exactly. So break is over. I mean, maybe the people that are outside, they will hear my voice and then maybe they will come back. If not, maybe someone can check. Anyway, I prepared now in this short break 2 more slides for the questions that were asked previously. once, yeah, I forgot to mention, we have right now an article under submission that is exactly explaining this string matching process, and you can find it, our draft at least. I mean, it's under review, we'll do some reviews, but the content and the technical part will not change anymore, and you can find it under the link that's written here. Yeah, and there's a screenshot also to show you. There's a Jupyter notebook, of course, and that's the article that we submit, which is also something that we're doing for the very first time. And yeah, check out the Journal of Digital History if you are curious about how that would look after submission. And there we explain like how we did it and like what is the minimal data set to do this, and yeah, our method basically. Yeah, and the second slide was for the question of how do we find the books now, and as I mentioned previously, like we need to find this specific search facet of previous owner. And in this field, one of our librarians entered Prince Eugene for the ones that we matched. Yeah, and then you can see, I mean, maybe you cannot see, but then I can tell you there's like around a little more than 10,000 books that were entered in the catalog this way, and yeah, if you compare it to the original figure of 15,000, then we are still short a little bit, but we're not off by like all of them. So that's good to know. Anyway, now I think, exactly, I will have 20 minutes to talk to you about this newer project that we're doing right now at the library. And that's about creating OCR, so, you know, optical character recognition on historical documents, and to make it more general. But first of all, I will start with a specific project and outline you the problem, because we have so many pages and so many of them were scanned, but not all of them got the full digital treatment. As in, you know, you have an image file, but you have no idea what's on it. You maybe have metadata, as in the title of the book, but you don't have the content. And this is a part where we as a digital library want to, you know, push forward, because things that cannot be found, they are lost. Like why even show the picture when the content of the picture is not available through any search portal? And yeah, this, you can compare this when you take a picture with your phone and you use Google Lens on it, that yeah, your phone tells you what's in the picture and can translate you a menu, for example. Yeah, and the collection that we're working on was the collection of pamphlets, in German Flugblätter und Flugschriften, that we have at the Austrian National Library. That's another one of the important ones. It dates like from a range of years. So the full collection is from, you know, late 17th century until 1915, but the bulk of them are from the years around 1848. And if you know your history, you will know that there was a wave of revolutions in Europe during that time, and publication formats also reflected what happened during that time. So, you know, it was so important to get out your statement. You couldn't write a book about it and then publish it 2 years later. So people were publishing little pamphlets, 1, 2, 3 pages with political messages, or maybe not so political. And yeah, some of them, or we hope many of them, were preserved, and they ended up at the National Library. I mean, mainly because the ministry was collecting them, and then finally they got to us. But also Freiherr von Helfert collected some of them himself and then donated it to the library. Yes, and it's really interesting because this is like a record of public voices and debate, and yeah, the project name Viele Stimmen, Many Voices just describes what's in it. And here I brought you a picture of, like, it's a collage of many of these pamphlets. You can get a glimpse. There's like many different languages. There is illustrations. There is like weird fonts that are curved or even like almost illegible. And yeah, that explains why this project was difficult, or like, you know, why it wasn't I start one command and I come back a month later and everything is done. And yeah, a couple more details about the project. It was running for 16 months. That includes the whole life cycle. And we were doing it together with the House of Austrian History, which is also part of the Austrian National Library. which is a contemporary history museum. So they had more recent things that they were digitizing, but pamphlets were in our collection, of course, and you can see here we have around 38,000 scanned items and scanned pages, that is, that belong to 20,000 objects, and and many of them were cataloged for the very first time, because previously it was realized that these items are important, so they already were digitized, but that was, I think, around 20 years ago, and therefore the quality of the scans is really bad. It was, black and white, and nothing in between, so not even grayscale, and that's really like a big challenge to recognize the text. So we applied for funding. We got funding to digitize it, and then we have it now in high resolution, and that means we could do the full life cycle. The conservation aspects were looked at because these pamphlets are they were not made to last. They were made to send out a message, and maybe they should last 1 week, but they were somehow conserved in a way that we can still look at them today, but they're falling apart, many of them. So the conservation has to be the first thing that you look at, and then you should catalog it so that it's available in the library, in the system. Then it will be mapped to a data model, and the author and anything or the subject in the text will be mapped to normed data. And then in the German-speaking world, there is a normed data file for this, and I believe, many other libraries have other files for this, and then it will be digitized, and finally, that's where we come in, we create text for it, and then it can be published to the world. So then, we are one important step in this big chain of the pipeline. And without the text, the content is basically lost, because the title and the keywords, they tell you one thing, but they will not tell you actually the contents, or maybe the title was sarcastic. You will only know if you read the whole text, and then you will know what is the meaning of the whole thing. Is it a joke? Is it serious, or anything else that you might want to find out? So with the full text, you get the full picture of the collection, and that way other researchers can also do their own research, because as a library we also want to open up the collection and not do the things that we do and then tell others, you should see it the same way. But the whole collection is big, and it's multilingual, it's messy, it's historical. You can see on the right side the final boss of OCR. So that's a huge wall calendar, and it's, I don't know how many megapixels as it was scanned, and we still couldn't run OCR on it yet. Or as in, we were not sure what the use of it is, because it is just a calendar with the saints' names on each of the days. So the historical content, or the historical meaning of it wasn't deemed that we should put more effort into actually getting the text out. But I just like to use it as an example, because it is a very big picture, so that gives you already trouble computationally, and also the layout is very tricky. It has multiple columns, it has a typeface that is hard to read, and it also has graphical elements in the upper part that at this resolution you cannot see them, but there is the year 1831 of this calendar, and also the name that it's a wall calendar is also written, and all of this you would like to get out. And luckily this one is in German, but we also have other languages. So I've written down that we have here 7 languages that there is a lot of, and then there is even more. So in total we have 28, but just a couple objects of each language, and then out of these 28 we cannot even do OCR for 6 of them, because there is just no, we have a question in the middle, there is just no data for it, we wouldn't recognize. Okay. Yeah, there's a question in the middle. I think we need the microphone.
This is a good point just to ask, do you remember maybe which of these 7 languages are the most problematic for OCR segmentation and recognition because of this problematic maybe syntax?
Yes, so The Latin typefaces are not so problematic, but there's Polish, there's Hungarian, there's Czech, and these ones have lower scores in our metrics. But I will come to the metrics later, because there's also the difficulty of how a language changes over time. The spelling changes, and the modern dictionary of a language does not reflect the quality or like the words back in the days of like 300 or 200 years before. So then, it's just a relative measure. But I can tell you anyway that, these languages gave us trouble, but also German because of the Fraktur type fonts. Yes, definitely. Like it's just hard to read, and yeah. Okay, and exactly, I have to speed up a bit because we only have 10 minutes left. So I will maybe, go a bit faster on some parts. But I like this slide because it shows that what we did in the beginning to check if our method works actually worked. So you can, in a couple of words, I mean, I will skip the details on the left side, but you can see, previous work is the leftmost column where you can, you get a nice flag of some country that I don't recall, but it means, there's a couple pages that are in good shape, then other pages that are not, and then also a lot where it's like completely not up to speed. And then if you do some, easy stuff where you just use Tesseract for text recognition, then it already gets better. But if you add to it layout analysis before the text processing, then you get the best results. And that was our idea of this project, to, combine layout analysis with a machine learning based algorithm together with normal text recognition that doesn't require a machine learning. Or I mean, by now, we already think of it of not machine learning because the machine learning has been done and we don't need to do it. We just run the program. I mean, it's funny how that changes our perception because what the computer can do is not AI anymore, or what the computer standardly does. Okay, so this I will skip. Like our project was based on a previous project, and I will rather show this picture because it's easier to understand what's going on. So the layout analysis is the first step. So you can see there's a title page with given an easy layout, but otherwise, I cannot show how nicely the layout analysis works. It recognizes title and text fields and illustrations, and then we suppress illustrations, and we cut out title and text fields, and then we run text recognition only on the little images. And then, there are some things which are hard to recognize, as the Fiaker type is very hard to read, because that's like a custom font that the guy wrote on that at that point. And then, we lost the screen, so I have to speed up even more. Okay, it's back. Anyway, after the project, what did we do? We have around 90,000 pages that we OCR'd. So during the project, we found also more boxes, like in the holdings, that were never seen before. So the pages, the number of pages went up, but we also tried to read the previous scans. So, we doubled the number of pages for that also. So then we were like, okay, we're already at it. Let's try to read the old scans and the new scans, and then we take the best result out of them. And here you can see some figures of which languages were good. Italian was pretty good. I don't know why that is. Maybe the Italian pamphlets used language that is used still today, and the dictionaries that we tried for checking these languages didn't change much. And yeah, this is just my suspicion. And then the Arabic ones were not recognized very well either. So on the right side, you can see an example of this. There is Italian writing, and then Arabic in the middle, and then Italian again. So it's a really hard thing to run OCR on. And so this variance in the quality is really important to show and to see, because if you don't know it, then you would think, this text is all good, but it's not all good. It depends on the language, and it depends what you want from this text. Because if you search for words that are just not there because they were not recognized, then you might think, they are not there at all, but that might not be true. Okay, and this part I will fast forward even more. So the project was finished, but then we thought, how can we do this for other things? And on the right side, you can see a prototype that we're developing right now, where people can enter any object and then the result should be the text. So there's a picture of how the thing would look like, or a diagram of what all the technical things are, and then there's a user. The user will start a job, and then the job will get sent to a worker client, and then the result comes out and is written to a database. And yeah, where are we there? Where are we today with this project? It's right now in a prototype stage, but hopefully, you know, eventually everyone will be able to use it for our digital objects, of course. And yeah, the next thing that we want to do in this project is to create texts for the Alex collection, so the historical Austrian legal and legislative texts. Okay, I might skip to the takeaways. Yeah, what did this project do? We had a project name, and now afterwards we actually have searchable texts. And yeah, as I mentioned, it's never, you have to be aware that and only the things that got recognized are then searchable. Yes, and the previous project that I presented, but also Sonja's project, there's actually the same pattern that, like, how do we make things accessible and how are we honest about the limits of what is accessible? Because only then you can put meaning to the things that you find. Because if you don't know what is missing from your search, then how much can you trust what you found? Okay, this brings me to the wrap-up. So, because it was a long lecture, I just wanted to bring back, like, what did we do, what kind of sources did we see, and what did we do to it, and then what methods did we use. So for the first project, the Library of Prince Eugene, we had a couple sources. Some of them were analog that were then digitized during the projects. Others were already digital, and namely the books that were digitized in collaboration with Google and the modern catalog, and then the handwritten catalog was transcribed during the project. And yeah, the other projects, namely the Jupyter Notebooks project, they used various digital archives already, because otherwise, you know, it's outside of our scope. And the OCR project already started at a digital world. And the problem is always something that where, you know, normally you would stop because there isn't just any data, or you cannot continue whatever you want to do. So with the Eugeniana library, there is just, you know, we didn't know what is it, where does it end? Because if you just collect all books from the State Hall, then that's too many. And the same for the other projects where it's just we cannot search it, or we have metadata that come from different sources and we cannot trust it because we don't understand it, and so on. Yeah, the core methods that we explained a little bit were handwritten text recognition, image recognition using machine learning, and fuzzy string matching. For the Jupyter Notebooks, we had data enrichment, geocoding, so localizing points on a map and then visualizing them, and most importantly, also packaging them as reusable notebooks that other people can use, that other people can understand and change, and then use them for their projects. And finally, for the OCR project, we used OCR. I mean, that's the name, but also we developed this custom pipeline for layout detection. And of course, that worked nice for the pamphlets, but it doesn't work nicely yet for the newspapers we have. Because newspapers have even more complicated layout with multiple columns and illustrations in between, and we're still working on that. Yeah, and finally, what did we get from the structuring of our data? For the Prince Eugene's library, we have this collection that we could visualize. So there is a data set that is for people who want to work with data. There is an interactive visualization for people who just want to explore. And there's also a digital edition of the handwritten catalog for people who want to go back in time, because the handwritten catalog is the status of 1738, and you know, we might not have all the books in there anymore because some might have been exchanged for other books or sold or lost, so we don't completely know about that. For the notebooks, of course, there is a data set that you get from running the notebook, and the notebook itself is a template for the next notebook you might use or might want to create. And of course, for the text we then get a text corpus all in one place, and yeah, we can further expand it and make it more searchable. Yeah. Okay, and for the discussion, where we have now 10 seconds. No, I just wanted to bring, you know, one starting question that is about uncertainty, because some uncertainty I talked about, you know, classifying things. The classifier gives you back a probability, like how certain is that, and image recognition for layout analysis is on the right side. That also comes with some uncertainty. So then, whenever you know you do something, how certain are you, and how did you visualize this uncertainty? And yeah, if you have some opinions on that, I'm happy to hear it. But otherwise, I would close the lecture here, and thank you for your attention.
Thank you. If you have a very last question, we can take one. Yes.
Yeah, thank you so much for this very interesting contribution, the lecture. You mentioned a few times your collaboration with Google, and I'm like very curious which part did they play?
This is the Austrian Books Online project, and it started already, when did it start? 2012? I don't know, some years ago. You can look it up on their webpage. Maybe I can give you the link. But it's a collaboration, a public-private partnership with Google, where historical books are digitalized. That means, you know, we send them to Google, they get scanned, and then the books come back together with the files of the scans. And that is at no cost to us. Google does this, and then afterwards the books are publicly available through our interfaces. And there is a deal with Google that they can use it commercially for 15 years, and afterwards other people also could. But until then, there are certain right restrictions on these images, but you know, not on the text data, for example. So there is like, we thought at the time that it was a good deal, because that way we could digitalize the whole State Hall at no cost to us. So it was a big achievement back in the day, and I think we are still happy with the way it works, because the quality and the whole pipeline, how it works, is really good, because you know, we didn't lose any books, no books were destroyed or damaged during all of this, because they have high quality standards for all the scanning, and we're in close contact with the scanning centers. And I mean, other libraries also in Germany are doing the same. So then it's not, you know, it's not a big risk for us, because it's happening everywhere.
Thank you. And with that, we conclude our day today. Goodbye.
Yeah, thank you.